9.5 Resistors in series and parallel. Part 2. What if you have a circuit that is partially in series and partially in parallel? Of course, that makes it more complicated. But what you do is you'd simplify any series portions of each branch. You'd do the parallel circuitry, combine the branches together. If there's any more series stuff after that, you'd do that. It looks something like this. Okay, it looks complicated. So it's kind of like math, work from the inside out. So we have some parallel portions we could combine. And then that gives us a series portion on that branch. And then we could combine those parallel portions, which then gives us a series we could combine. And then we're down to the equivalent of one resistor. That's the goal of what we're trying to do. So we're going to find the equivalent resistance and the total current in this circuit. Okay. All right, let's start by drawing it as a circuit diagram. And then we're going to look at each individual branch. There's one branch here. Well, that's just a single resistor. And another branch here. Well, that branch has two resistors we can combine. And since they're one right after each other, the current doesn't have a choice for going from one to the next. They are in series, so we're going to combine those. So we'll have 5.170. This was 5.17 originally. Ohms plus the other one, which was actually 10.09 kilo ohms on the previous screen. So that's 10.090 ohms. And that adds together to make 15260. So I can now redraw my circuit where those are a single resistor. 15.26. My software to draw the diagrams rounded everything to one decimal place. Now we look and see, oh, this branch is one resistor, this branch is one resistor. And I know those branches because we have these nodes where it's where the current has a choice and splits. So what we'll do is we'll now combine those two parallel branches. So 1 over R equals 1 over 15260 plus 1 over 100,900. So I put them all into our base unit of ohms. So 1 over R equals 7.54 times 10 to the negative fifth per ohm. Going to reciprocal both of those. So if R over 1 equals 1 ohm over 7.54 times 10 to the negative fifth, which is 13255. So those combine into one branch with equivalent resistance of 13,255 ohms. All right, so this was 13.255 kilo ohms. All right, now we just have one loop. So since the current can't split or go anywhere else, has to go all three, these are in series. So we'll just add these up in series. So I have the 101 on top 13255 on the left, and this was 1004 on the bottom, if we look at our original diagram. And that gives us 14360 ohms. So that would be essentially making a single circuit like that, where we had the equivalent resistance of 14.4 kilo ohms. Let's try another. Find the equivalent resistance of this circuit. Again, it helps to draw the whole circuit out. Fill in the numbers that are actually measured. Just so we have them. All right, so we need to look and see. So we come up and split here, but then we go through and then it splits again. So we're going to actually start at the end where we have the furthest split. The current could go either way out here at the end. So since that's in parallel, it'll be 1 over R equals 1 over 1004 ohms plus 1 over 100,900 ohms. Okay, so 1 over R equals 0.001005927 per ohm. So if I reciprocal those, that should give me about 994.1 ohms. So I could replace those two resistors, those two branches, with one resistor of 994.1 ohms. So now we've got this outside branch that has two resistors in series. Let's combine those. Remind you that this one on top is actually 5170 ohms. So since we're in series, we just add them together. Which gives us 6164.1 ohms. So I could replace both of those with a single resistor of 6164.1 ohms. Okay, so this one over here on the right was 6164.1 ohms. This one in the middle was 10090 ohms. So now we just have this parallel circuitry, so we can combine those. Since it's parallel, it's 1 over R. Okay, so 1 over R is 0.000261338 blah 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 over ohms. It's way too many decimal places. Reciprocal both sides, and we end up with 3826.5 ohms. So I replace those two parallel branches with that. So this is really 3826.5 ohms. And now these two, it's a single circuit, so that means they are in series. So I can combine them in series, just add them together. Which gives us about 3927 ohms. Which could be done as a single circuit looking like that. The single resistor